In last session, we discussed about the breakdown in gaseous material. We discussed Townsend theory, how primary ionization occurs, how secondary ionization occurs. And in this session, we will discuss factors affecting on the breakdown voltage. So let us see how breakdown will change with different factors. So this was the yesterday's discussion about primary and secondary ionization. When we apply variable voltage, then how conduction starts in the gaseous material, and how cathode and anode plays role in that conduction, how secondary electrons will jump into the gap from cathode surface, how free electrons will come from the gas molecule. So just now we can just see this figure. So conduction current insulating material breakdowns means current will start. Current means flow of electrons. This means in short that there will be free electrons between the gap. Now here there will be no gas molecules. No gas molecules means more and more gap will be filled up with the free electrons. And when gap will be filled up with free electrons, we can say breakdown of that air or breakdown of that material has occurred. And all these free electrons will be moving, these free electrons will be moving towards anode, because anode is positively charged. We are giving high positive force in kilovolts we are giving to the anode. So all these negative charge electrons will be rushing towards anode. Means electron will move from cathode to anode, means current will start flowing. But what will be remaining from the gas molecule? Remaining from the gas molecule will be positive ion. Positive ions are heavier than electron. So by the time these free electrons, which are light than positive ions, because mass is less, they will be rushing the gap. They will be reaching towards anode. By that time, positive ions will be just moved little bit. But these positive ions will also have large force of attraction with the cathode, because cathode is negatively charged. This high potential, negative potential we are applying towards cathode. These positive ions will bombard on this cathode. So don't confuse with this arrow, but positive ions will come like here and they will bombard on the cathode with a very high force, and due to that electrons will jump from this cathode surface in the gap, because cathode is conducting material, brass or copper, and you know conducting material means valence electrons will be there. Valence electrons will jump from valence band to the conduction band easily due to the kinetic energy given by this positive ion, and then electrons will dislode from its atomic structure of cathode material, and they will jump here in the gap. Again that electrons will rush towards this anode, because they are free negative ions, and here very high positive force is there. So same way electrons from the gas molecule, how they will rush towards anode, same way electrons from the cathode will rush towards anode. Only difference is that these are electrons due to the primary ionization, means liberated from the gas molecule due to impact of free electrons, because this free electron will collide with the gas molecule, and again it will dislodge free electrons from the gas molecule. So the process of collision of free electrons with the gas molecule and liberating free electrons from the gas molecule is primary ionization, whereas process of electrons liberated from cathode surface due to impact of positive ion is secondary ionization. And after primary and secondary ionization, avalanche stage is there. Fourth stage is avalanche. Avalanche means number of electrons will be there in the gap. Electron multiplication 1, 2, 4, 8, 16, 32. I explain you. So this is avalanche. So avalanche is the electron multiplication process. Okay. So that's about the revision. So just see the animation, because I told if you will visualize that will better to understand. So I just try to collect some animation. Just watch it. See what happens to this initiating electron. See, this is suppose gas molecule. Initiating electron has come. Now, what is the reason that initiating electron will jump near the cathode? This is cathode and this is anode. Ashok. What is the reason that initiating electron will jump in the gap? We discussed that reason. So try to recall that, because I am conducting test now, quiz. And we'll see who will just win that competition. Okay. So I am giving you the points to remember. See, now initiating electron has collided with the gas molecule, electrons from the last orbit of this gas molecule. And what will happen? It's moving fast. Electron is moving fast because electron is free and here it is the positive charge. So kinetic energy of this electron will be electron or it might be photon. There are number of reasons we are going to discuss in detail. So that will be colliding with this electron. So kinetic energy of this will be given to the electrons from the gas molecule, and therefore energy level of these electrons from the gas molecule will jump, and this will be disloaded from the atomic structure because this force of attraction will be less and this force of attraction will be very high because we are applying very high voltage, and this will also start moving towards the anode. See, this is primary ionization. Okay, so this was the fantastic animation. So I hope now you will understand the primary ionization. Now this can be photon. So we are going to discuss in next lecture what are the reasons for this. What is photon and this? Okay. So ionization radiation like photon or X-ray. So therefore, as they are explaining with radiation, figure is shown like this. So radiation is moving towards the gas molecule electron, and again this free electron will collide with the another gas molecule. Now there is no need of only radiation, this will be just collide with another gas molecule, so it is called as ejected electron, free electron. So when free electron will collide with the gas molecule, that is primary ionization. Okay, and now see this ionization by photoradiation also.
Ionization of gas by photoradiation. Understanding photons. To begin with this discussion, let's understand the
Sound is coming, na? Sound is coming, yes,
Yes,
or
ma'am.
no? Okay.
Yes, ma'am.
fantastic particle called photon. A photon is an elementary particle, the quantum of all forms of electromagnetic radiation.
What happens? Somebody change my sharing. Huh?
The photon has zero rest mass, which means it consists entirely of kinetic energy. The modern concept of photon was developed by Albert Einstein. With time, the scientific development established the wave-particle duality of light. Energy in photon. The benefit of the photon model was that it accounted for the frequency dependence of light's energy. Max Planck showed that the energy of light is proportional to its frequency, also proves that light exists in discrete quanta of energy. The photon energy, E, can be mathematically given as the product of Planck's constant h and frequency v. Take a look at the energy equation. Ionization. Being a carrier of energy, these photons facilitate ionization. Before knowing how it is done, we need to understand what is ionization.
See, I told you reason for initiating electron in the gap is illumination in the gap, in the lab. Light is radiating. So light is radiating means what? It is just photons because illumination is in the radiation form. So that is photon, and here I am demonstrating with animation how that light in the lab will initiate the ionization process with the photon or with the radiation. Okay.
Ionization is the process by which electrically neutral atoms or molecules are converted into electrically charged atoms or molecules called ions under the impact of a high energy source. Photoionization. The source of energy can be anything that can break apart the nuclear structure of an atom. Let's see how it happens when light becomes the source of energy. In photoionization, the electromagnetic radiation of light hits the matter, resulting in transfer of energy to atomic structure. A high-energy photon collides with a neutral atom, resulting in transfer of energy from photon to neutral atom. The process results in dissociation of matter into electrically charged particles. The simplest example of this process can be seen in photoelectric effect, which occurs when light shines on a piece of metal, causing the ejection of electrons. That is all.
So here you have seen when light impinges on cathode, the electron, free electron might be from the electrode surface. Okay. So that is photoionization. And also you can just see initiating electron can be from the cathode. So it is a cathode emission. So injection of electron you have seen due to light energy, because here energy is given to the valence electrons from the conducting material of the electrode. So they will jump from valence band to the conduction band. Jump means higher energy level. Means it will be away from its positive charge nucleus. And it will be dragged here due to the other positive force of attractions with the anode what we have given it. Okay.
About photoionization. Recap. In this lesson, we learnt about the concepts of photon, ionization, and photoionization.
Okay, students, are you listening? Students?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So that was about the revision, whatever we discussed
Ionization.
yesterday and today. Now we will just see the competitions. Okay. So go to kahoot.com. Students, you go to kahoot.com, not kahoot.it. Kahoot.com, you just go. Okay. And let us see how you will play this game competition. Go to kahoot.com. So now we'll play the competition. Just go to kahoot.com and enter this game pin. It will come here on the screen. Game pin will come. My network is weak today. Enter, students, enter game pin 4014 4014677. Enter the game pin. Be quick. And your time response is very important. Time response is very important. Okay, because depending upon your time of response, score will come. Congratulations, Roshni, Prathamesh, Aditya, very good. Quick response, you could join it. Come on. Fast. All students will not able to play. Only fast students will able to play. Because time is very important. So come on. So students, I will just start playing it, okay? So breakdown in air. Now here you have to just click on the right color of the answer, okay? So first question, ionization in air. Ionization in air has following stages. Click the proper color. You will just see the color. Whatever answer you see, click on that color. Come on. Click the answer. Just fast. Come on. Okay, so 11 students could give correct answer. Okay, so congratulations to 11 students. Who are those 11 students? Let us see who are those 11 students. Okay, so correct answer was ionization in air has following stages. Correct answer is all. Just now I revised primary ionization, secondary ionization, avalanche. Initiating electron is also there, but it is not included. Okay, so all is the correct answer. Let us see who could. Okay, Anjali, congratulations, 822. Aditya, 761. Hussein, 748. Tanvi, 738. Mitesh More, 698. Very good. Let us move on to second question. B students, come on, jump in fast. Process of electron multiplication. Process of electron multiplication is called as breakdown voltage. True or false? Select a color. Select a color. Fast, 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 fast. All 20 students. Come on. Come on. Only 80 could give and 12 could give correct answer and 7 are wrong. Process of electron multiplication is called as breakdown voltage. False. It's called as avalanche. Students. So again Anjali, Hussein, Mitesh, Keyur. Okay, Keyur and Prathamesh have jumped in. Good. Now try to jump into the fast. Try to beat Anjali. Next question. Electrons liberated from cathode, it's called secondary electron. Electron liberated from cathode, it's called secondary ionization. Cathode or anode, any? Come on, all 6, 5 Good, good, good. Now 21 could give. True or 17, but 4. You missed my lecture. I think yesterday's and today's also. Electrons liberated from cathode is called secondary ionization. Correct. And here I will tell you not only cathode but same anode. Same thing happens from anode also. Okay. So that you always remember. For confusion, I am not telling you all, but that is always from both electrodes. Anjali is doing very good. Mitesh More, Keyur, Prathamesh, Gayatri. Okay, Gayatri. Now last question. Let us see. If gap distance is increased, then voltage, breakdown voltage will. If gap distance is increased, then breakdown voltage will. I think. Come on, fast. Come on, fast, students. Students, fast. 8. Okay. Let us see. Only 7 could give 8. Where if gap is increased, then breakdown voltage will increase. Why breakdown voltage will increase? Because each electron has to cross over larger gap. So voltage will require more and more to attract that electron to reach cross over the larger gap. So gap distance increases, breakdown voltage will increase. One student has given false answer. Now let us see who is the winner. Okay, Anjali, congratulations. Keyur, Prathamesh, Aditya, Neeraj, congratulations. Now, what about other students? I don't know. So, only 4 students are there where capacity is of 20 students. Okay. So, you must learn to respond in very fast way. Students, let us move on to our now session. So just see how you answered and what was the revision test and how you understood the concept.
Ionization.
All these concepts are very, very important. So have the snapshot of these questions and again be prepared for that. Okay. Because your test will be MCQ and then you have to be ready for the test also. So let us now discuss the factors affecting on the breakdown voltage. Okay. So what are the different factors which will affect on the breakdown voltage? So we have seen first breakdown voltage, breakdown strain. So these are the factors affecting on the breakdown voltage. Applied field. Applied field means how we are applying the voltage. And I told you yesterday concept of electric field intensity. So what is the voltage applied and what is the electric field intensity in the gap? So V divided by D, radius of curvature of the electrode, not the gap distance D. So radius of curvature of electrode R is electric field intensity. So if write down, if electric field increases, breakdown voltage will dash dash. Write down, fill up the gap, and then you discuss. I am asking you oral responses. Who will explain? Then second, if gap distance increases, breakdown voltage increases. Just now we have seen. But who will discuss why that gap distance increase in gap distance will increase the breakdown voltage? Okay. Then cathode work function. What is cathode work function? To liberate electrons from electrode surface of cathode, some energy we need to give. You have seen the photoionization. We have to radiate high extra energy wave on the electrode surface. So what is that energy required by cathode to liberate free electrons is known as cathode work function. So if that energy will be higher, what will be impact on breakdown voltage? Then temperature of cathode. If temperature of cathode or ambient temperature or surrounding temperature is higher, breakdown voltage will less or high. Fill up the gap. And I will just ask you to give oral reflection. Let us see who can answer any one factor. Any one factor you have to discuss. Okay. Size and shape of electrode. If size of electrode will be increased, size of electrode will be increased, diameter of electrode will increase, what will happen on the breakdown voltage? Breakdown voltage will increase or will decrease, and just think why it will increase, why it will decrease. Okay, because you have to think. Thinking process is very important, and in the oral exam always examiner observe how you think. What is your logical thinking process? Direct answers are not important. Even if you will give wrong answers, but somewhat justifications and your logical thinking, it gives you good marks, because thinking has to develop. And I'm expecting you will think on all these aspects. Students, have some time, think and try to explain in your own word any language, but try to say something, try to think that, and then only we'll see direct effects. So if diameter of electrode increases, breakdown voltage dash dash. If shape of electrode will change, what will be effect on breakdown voltage? Why it will be effect on breakdown voltage? I would like to conduct brainstorming on this. Yesterday only I told you. Material of electrode. Suppose electrode cathode is of copper. What will happen? If cathode is of steel, what will happen? If cathode is of gold, what will happen? Will it affect on breakdown voltage? If it will affect on breakdown voltage, why and how? Suppose I will change electrode from cathode to gold. If cathode to gold, breakdown will be earlier or at higher voltage. Write down. If electrode is changed from copper to gold, breakdown voltage increases, decreases. The next factor, the thickness and density of material. If material in the gap is thick, means gap distance is increased. And if density of materials, means suppose now gas molecule will discuss, and if suppose gas pressure is very large, means density of that gas is large, means you can just see number of molecules, number of atoms will be large. Breakdown voltage reduces or enhances, is higher or less. Complete that. Applied voltage waveform. Suppose I am applying the applied voltage sinusoidal or square wave, triangular wave. Whether breakdown voltage will change? If it will change, how it will change? Think it. All of you think on all the factors. For 5 minutes I will give, and then one by one student will just start unmuting yourself and will discuss any one factor. Okay. See, this is the practice for oral examination I am taking. You are thinking I want to develop. I don't want to just move on the portion. Okay. So frequency of supply. If suppose I am giving frequency 50 hertz and breakdown voltage I got 30 kilovolt. Now if I will change frequency to 60 hertz, breakdown voltage will be higher or less? Explain that. Dash dash dash. Frequency increases, breakdown voltage increases or decreases. And last, rate of change of voltage. Rate of change of voltage. Yesterday I told you 2 kilovolt per centimeter, 2 kilovolt per second should be uniform rate of change of variation of the applied voltage, because we are increasing voltage continuously to find out breakdown voltage. And if I will move fast changes, 10 kilovolt, 20, 30 fast, what will happen to breakdown voltage? If I am changing slowly, 10 kilovolt 1 minute, then 20 kilovolt 1 minute, what will happen to breakdown voltage? So if rate of change of voltage is higher, breakdown voltage is lower or higher. And last factor you just note down, dust particle or impurity. If there is impurity in the material or dust particles are there, breakdown voltage is less or high. Okay. And this will be the discussion which are very, very important for 4 to 5 experiments. Oral discussions will be just only on that. So let us have brainstorming on that. Students, take 5 minutes and just immediately don't ask me else. Just start unmuting yourself and I will be declaring just who will be winning this game. And say any wrong answers. Say any wrong answers. Wrong answers are welcome. Because if you'll give wrong answers, then only your concepts will clear. So don't hesitate for your answer because in brainstorming, anything you have to say. Okay. So just take 5 minutes. Yes.
My name is Neha More.
Okay, Sneha More. Good. Huh.
Ma'am, impurities increases, then
Huh.
dielectric strength increases, and breakdown voltage is decreases.
Okay, good. So Sneha is saying that if we will add impurity or impurity is there, then breakdown voltage will decrease. Because see, when dust particle will enter in the gap, that dust particle or impurity, in gas we'll say impurity means dust particle, in liquid we'll say suppose water. So if dust particle will arrive in the gap, what will happen? The dust particle is free to move, very light and free to move. So when it will fall in the gap, immediately it will be forced towards the electrode. It will force towards the electrode because electrode is highly charged. So if you'll see this figure, electrode will be highly charged. This electrode is highly charged. So dust particle is suppose here in the lab or in the testing room. Immediately it will be forced towards the electrode, any electrode. Let us see it will be in the cathode because this is a very high force of attraction. So it will just come in the vicinity of cathode. Cathode is negative. So that dust particle will become negative. And now here we got the one free electron or one free ion for the process to start. So that dust particle will become negative ion, negatively charged, which is very free to move towards the anode. It is not like gas molecule tightly held up with the force of attraction with the positive charge nucleus. No, dust particle will become ion, and negative ion will be forced towards positive charge. So process will start. Correct. Good. Sneha, good. Now any another student? Can you tell me effect of temperature? If temperature is increased, what will happen in the breakdown process? If temperature, ambient temperature or temperature of electrode is higher, breakdown voltage will be lower or higher? Anybody?
Ma'am, it will be lower.
It will be lower. What's your name?
Ma'am, my name is Aditya Bhopale. Ma'am,
Okay.
if temperature is higher, the breakdown voltage will decrease as the electrons in cathode will get more energy for liberation.
Very good, Aditya. Congratulations. So, Aditya Gokhale is answering that if temperature is higher, breakdown voltage is low. Less. Very good. Because see, temperature is higher means what will happen to this gas molecule? The electrons from the last orbit of gas molecule is having thermal energy. Thermal energy means as good as energy wave radiation. You have seen the effect of radiation. So thermal energy means thermal radiation. Means energy of valence electron, electrons from the last orbit of gas molecule or from the atomic structure of cathode will become higher, and energy of electron is higher means it will jump from valence band to the conduction band, means electrons will be away from the positive charge nucleus. Away from the positive charge nucleus means will be very easily dragged by this higher electrostatic force which is there. So here assume the gas molecule temperature is higher, so electron will be excited and it will be away from its own positive charge. That means it will be higher, means easily dragged by this anode. Suppose temperature of this cathode is higher, so work function will be less. Means less energy will be required to drag electron from the cathode function. because already temperature energy you are giving, thermal energy you are giving, and then electrons will be immediately moved. You just imagine yourself in this room. Suppose you are in this room and I am just controlling the temperature of this room. And as I will move on temperature, just your agitation will start. You will be moving your hand, you will be wiping your this sweat, and hush and whoosh, and all these things will happen. And still I will go on increasing the temperature of room. You will run away from the room. Okay. So the same thing happens with the electron. And this is also called as thermal agitation. Thermal agitation means random movement will start. Okay. Yes. Anybody want to say on this? Yes. Okay. Now next factor, if suppose this diameter of the electrode is increased. Let us discuss that factor. Diameter of electrode or the size of electrode is enhanced. What will happen? If diameter is increased, breakdown voltage will increase. See this distance we have discussed. If distance is increased, breakdown voltage will increase. Okay. Why? Have you understood this? If distance is increased, breakdown voltage will increase. Because see, distance is large. Means here gas molecules will be, number of gas molecules will be there. But electrons has to cross over that larger gap. And therefore large force has to be there. Means higher voltage. Means gap distance increases, breakdown voltage will be higher. Okay. Now shape of electrode. Let us discuss shape of electrodes. If electrodes are spherical, what will happen? If electrodes are rod or plate, what will happen? If electrodes are needle shape, pointed electrodes, what will happen? Suppose I got the breakdown voltage for this plain electrode 30 kilo for 1 centimeter gap. Now gap distance is same. Here it is not same, but suppose I will keep the same gap distance, whether I will get breakdown voltage 30 kilovolt or less or higher. What do you want to say? Yes. What will happen here? For the same gap distance, if pointed electrodes, needle electrodes, pen type electrodes, I will select. What will happen? Thinking is very important, and just answer any random things. Because if you will say anything, more and more concepts will be cleared. So in brainstorming, you have to say anything. Other students have to cross out one say. Okay, that is called as brainstorming. And this you must be habitual for your placement, because in placement they just give any one topic to carry out group discussion. And if you are not able to open your mouth, and even if you don't know, or even if you know, you are not habitual to open your mouth, who will select you students? At least B students, you should be very talkative and responsive. Just have habit, developing habit of opening your mouths. In group discussion, you may not be knowing the points on that same topic, but you should learn the skill, how you can enter into the discussion, how you can jump, how you can start, how you can accept what other students are telling. At least you have to say, yes, I accept. You have to add something on the same point. Yes, just tell me what will happen with the point electrode. What will happen? Whether breakdown voltage will be less than 30 kilowatt or higher than 30 kilowatt. Students. Diploma holders. Govind Bele. Harshal.
Ma'am, less than 30 kilowatt.
Okay, Harshal, good. Why you think the breakdown voltage will be less than 30 kilovolt? Why you think breakdown voltage is less than 30 kilovolt, Harshal? That is correct answer. I told you electric field intensity concept. Okay, gap distance is same. But what is electric field intensity concept? Now see radius of this. This is suppose 1 centimeter. And we are applying 30 kilovolt across the electrode. So what will be electric field intensity in the gap? 30 divided by 1 centimeter, which is perpendicular distance to the lines of flux. Lines of flux will be like this. So the perpendicular distance to lines of flux is this. So this is 1 centimeter. diameter, suppose. Then electric field intensity will be 30 divided by 1 centimeter means 30, and it will be uniform throughout the gap, because here it is 1 centimeter, here it is 1 centimeter, so everywhere it is 1 centimeter. So what is electric field intensity? 30, 30, 30, 30, 30. This uniform from one electrode in the gap, another electrode 30. So that is electric field intensity. What will happen here in the non-uniform, or just when electrodes are point shape? What will happen? When electrodes are point shape, then here you just see the tip. So what is the perpendicular distance of the this electrode? Suppose 1 micron. 1 micron, this tip. So electric field intensity will be 30 divided by that 1 micron means higher. So electric field intensity will be very large, and breakdown voltage will less, because here you are considering 30 kilovolt applied. Here you are also giving 30 kilovolt applied, but intensity here is very large, and we have to discuss how breakdown occurs in this such a non-uniform field, uniform field. Here you can just see it is non-uniform. Here it will be 30, and here it will be very high than 30. So air surrounding this electrode, point electrode, will be ionizing very fast. So for such a point plate electrode, you may get 5 kilovolt only, not 30 kilovolt. So electrode shape will affect on the breakdown voltage, and if electrode shape is non-uniform, if pointed, then breakdown voltage will be very high, because electric field intensity will be high. And as high electric field intensity means ionization fast. Now suppose diameter of electrode is increased. Suppose here sphere diameters are only 1 centimeter. So same you can just see perpendicular distance. What will happen? And if gap distance I will increase 2 centimeter, then 30 divided by 2. So it will be 15 kilovolt intensity in this gap. So intensity will be reduced, means diameter increases, intensity will reduce. Intensity will reduce means breakdown voltage will increase. So if diameter of electrode is increased, breakdown voltage will increase. Write down. If diameter of electrode increases, breakdown voltage will increase due to reduction in the electric field intensity. This is one explanation. But second explanation is that if suppose I am keeping electrode diameter 1 centimeter, means how much air is there? Only this perpendicular distance is 1 centimeter, means only so many gas molecules. Suppose 50 gas molecule in this 1 centimeter gap distance of the electrodes. But when I will enhance the diameter 2 centimeter, then gas molecule will increase, because diameter of the electrode is increased, means gas molecules will be large. And if gas molecules are large, means more and more electrons will be in the gap. Means if diameter is large, breakdown voltage will be less. Write down. If diameter is large, then breakdown voltage will be less, because number of gas molecules will be larger, number of free electrons will be larger, more collision can happen, more liberation of free electrons will be there. Now, who is predominant over whom? Depending upon that, effect of diameter will be there. Write down. Which factor is predominant over what? Depending upon that, breakdown voltage will vary. Means whether this number of increased gas molecule is predominant or reduction in the electric field intensity, then definitely breakdown voltage will increase due to increase in the gap electrode diameter of the electrode. For mushroom shape, what will happen? You can just see electric field intensity will be higher than the sphere, because radial distance, perpendicular distance is less, means electric field intensity will be more. So mushroom shape electrodes, point electrode, breakdown voltage will be very less. Point rod means this is more uniform than that. Oh, okay, we are going to discuss this in more detail. One experiment is there for B class, breakdown of air in uniform field. This is uniform field, and breakdown in non-uniform field. This is weakly non-uniform field. This is highly this non-uniform field. highly varying non-uniform field, and you have to learn the phenomenon between these effects on this. But AC students can only just understand effect of diameter and effect of shape of electrodes. Okay, so that was one factor which will affect on the breakdown voltage. Not size of electrode I discussed. Size of electrode means diameter is increased. See, diameter is increased. What happened? Gap distance is same, but here number of molecules will increase and electric field intensity will also change. So discuss which factor is predominant over what, depending upon that effect will be there. And in that case, S by D ratio is very important. Write down. To discuss the effect of size of electrode, S by D ratio plays significant role. Now, what is this S? S is separation. S is gap distance. And what is D? D is the diameter of electrode. So, what separation you are keeping? And what is the diameter? What is this S by D ratio? So if S by D ratio is more than 0.6, effect will be different. So that we'll discuss by drawing electric field intensity, discussing on that. But here you only remember the factors depends upon S by D ratio. If suppose separation is more and gap diameter is less, so S separation is more and diameter is small, and separation is 1 centimeter and diameter is 2 centimeter, different effect will be there. Okay, so S by D ratio that will. Now what will be effect on material of electrode? Suppose I am taking copper electrode, brass electrode, steel electrode. I told you change electrodes from copper to gold. Suppose gold is very conducting material. So if my electrodes are made up of gold, made up of gold, then immediately electrons can be dragged from that gold, because gold is very good conducting material. So cathode work function will be less, means small energy will require to give to that gold electrode to drag electrons, secondary electrons. So secondary electrons coming from gold electrode will be very fast, and that will enhance the breakdown process. So breakdown will be very rapid, means at very less voltage breakdown can occur with gold electrode. But when you are changing from copper to brass, brass is less conducting than copper. So it's very difficult to drag electrons from brass secondary electrons, and therefore higher voltage is required for brass electrode than copper, and steel electrode will be again higher than copper and brass. Okay. So just read this what is given. Read this, that is explained in the words. If you are not understanding my words, you read that. So, students, you should be ready to discuss why it's very important. Why is important? Effect is important, but why is more important? And with only one question in oral exam, you can just score. Because if you will just explain all these things, it means that you understood ionization process. It means you have just thought over in detail. It means that you have studied in depth. Okay, that's why I am just taking one more lecture separate to discuss on this. It's just practical things. Okay, it's not included in theory. Means only you open any book, and you will just see the effect. Temperature increases, breakdown voltage increases. Only this explanation you will get. No, only this sentence you will get. No explanation. But explanation is very important. Okay, electrodes are changed, breakdown voltage will change. But why? Okay, so that you have to just discuss. And I told you additional factors also does cathode work function. If cathode work function is less, means what? Cathode work function is less, means with less energy, that electrode will inject secondary electrons. So if cathode work function is less, means breakdown voltage is less. Write down. If cathode work function is less, means with less energy, secondary electrons are available. Therefore, breakdown voltage will be less. Temperature we discuss. Material of electrode we discuss. Size, shape of electrode will discuss. Thickness of material. If metal is thick, definitely breakdown voltage will be large, because the distance in the electrode will be large. And density. If suppose density of material is more, means more gas molecules are there. More gas molecules means more atoms will be there, means more free electrons, and then breakdown voltage will be less. Now applied voltage waveform. Applied voltage waveform, suppose you are giving DC voltage and you are giving AC voltage. So what will happen? For DC and for AC, breakdown voltage will be different, because in AC always that anode cathode changing, anode cathode changing, anode and cathode is changing. Means this will happen rapidly because electrons will be scattered in the gap more fast. Okay, but for DC it is also important for which electrode you are giving positive charge, for which electrode you are giving negative charge. Suppose you are considering a rod plane gap and you are giving positive voltage to the rod, voltage will be different. If you are giving negative voltage to the rod, voltage will be different. So for DC, it depends upon polarity. Write down. For DC voltage, it depends upon the polarity of the electrode, and for AC and DC voltage will be higher. Generally for AC voltage is less. Generally for AC breakdown voltage will be less than DC, because in AC anode cathode will be changing and easily electrons will be scattered in the gap. Frequency of supply. If frequency is fast, means immediate changes happens. And you know when frequency is large, losses occurs. So for higher frequency, again process will develop immediately. Okay. And breakdown voltage will be less. And rate of change of voltage. Now rate of change of voltage, if you are changing voltage very fast, it means what? Immediately you are increasing voltage. Means suppose 20 kilovolt is applied, that will be only for fraction of second, unless that process will not develop. Immediately you have changed the voltage to 30 kilovolt. So that effect is also you have to consider, which is predominant over what, and what is the rate of change of variation. So IS includes the rate of change of variation in the voltage. So 2 kilovolt per second is always rate of change of voltage. Okay. And then dust particle. For B, more another factors we have to also discuss. This is just the basic factors. Students, go through this theory again, discuss the factors, think yourself, and then we'll move on for the further concepts in next lecture. So for today, it's sufficient. Okay.